All of the events for the past decade, all of our memories have something in common. They all took place during the hottest decade ever recorded, since humans began keeping temperature records about 150 years ago. In the last decade, the Earth's temperature was roughly third of a degree Fahrenheit. Since 1880, it's risen about 1.5 degrees. You might say the Earth is running a fever, and scientists predict it's going to get much worse. Already we can tell you the signs. Global sea level rose by over an inch during the decade, almost twice as fast as the average during the 20th century. Arctic summer sea ice declined by over 300,000 square miles, enough ice to cover the states of Texas and Kentucky. Real-life observations scientists use to perfect their predictions, and NASA gets a global view of the three major pieces of the climate puzzle. How much of the sun's energy is hitting the Earth? How much of that energy is reflected back into space, and how much is being trapped heating the planet? Could increased solar activity be causing global warming? Satellite evidence shows us that the solar cycle has only a slight impact on our planet's temperature. A second piece of the temperature puzzle is our planet's brightness, all other things being equal. A brighter, more reflective planet bounces more energy back to space. Some of the brightest, most reflective areas of our planet are those covered in ice. NASA imagery shows those areas shrinking, especially in the Arctic. As sea ice vanishes into darker ocean, our planet becomes less reflective and warms even further. More cloud cover increases the Earth's brightness, plus it will be helping to cool the planet. Many current climate models predict some cooling due to increased cloud cover. Will it be enough to significantly slow the warming? Scientists are using NASA data to look for the answer. Further complicating the issue is that water vapor is actually the world's most abundant greenhouse gas. That's right, the same molecules that might cool the planet in cloud form actually warm it when they're in the form of a gas. They help create a blanket around the Earth, catching heat, radiating the planet's surface, and trapping it within the atmosphere. As the planet warms, more water evaporates from the ocean, creating more of this heat-trapping greenhouse gas. Humans can't directly control the water vapor in the air, but we can have a much greater impact on other greenhouse gases. NASA satellite instruments capture the infrared signature of carbon dioxide in the global atmosphere. They show a rise throughout the decade. NASA also monitors other greenhouse gases such as methane, nitrous oxide, and CFCs. Greenhouse gases are most likely the main contributor to current global warming. It's a key piece to the temperature puzzle, and it's unlocked the door to higher and higher temperatures. 2010. It marks the end of the hottest decade we've recorded so far. What will the next 10 years hold for the Earth's climate? Computer models predict an even warmer planet with more extreme weather, less ice, and higher seas. The severity of those changes will depend partly on how our planet's complex system responds and more importantly on what choices we make.